Hello everyone, we are from Information System Department, Institut Teknologi 10 November, ITS Surabaya, Indonesia. We would like to share our work next gen Q&A Indonesian IT law with RAG and LLM. Next. So our motivation, we would like to know that legal research in Indonesia is very challenging. There's a lot of Indonesian IT laws. There is a volume and interconnection between regulation. However, the traditional search method only rely on the keyword patching. That's why we would like to integrate knowledge graph, RAG, and LLM. We aim to enhance legal information retrieval by providing context-aware and structure and explanation insight. Next. Next. Okay. Our dataset is obtained from the peraturan BPK from our government. We crawl that and then we use the custom web scraper. Then we use regex to extract all the information of the IT law. Next. Our dataset consists of nodes and its, with the nodes is consists of regulation, observation, definition, consideration, and article. And over that 2,400 article and nearly 1,500 cross-reference written often. This allow more meaningful and contextual query beyond the simple keyword searching. Next. What is the business problem? The business problem that we would like to address is the complexity, inefficient legal research, lack of visualization, and that's why we need the AI to assist legal reasonings. Next. Why we use knowledge graph? The traditional database only store the document that only capture, not without capturing the relationship. That's why the legal document usually they have the dependency admin reference between of the legal document. That's why we will be enable efficient requiring relationship analyze and legal reasonings. Next. Here our schema. For example, in here we have the UU ITE law number 11. 2008, which is content of the information transaction, electronic transaction information, and it was examined by ITE law number 19, 2016, and have the contents of several articles, and between the article there will have the relationship between the next article and refer to, and then for each IT law they have definitions and have include of consideration and observations. Next. Okay. How we load the data to ArangoDB? So we process the data using the JSON format, and then each regulation broken into articles with the metadata and on definition, reference, and admins. And in the ArangoDB implementation, we use the Vertex collection, its collection, and AQL. And here's the result of the next is the visualization of our regulations, consideration, observation, definition, and article. Okay, and then the demo will be presented by you.
Okay, now I will give an overview of the functionality of our GrapRAG. In our GrapRAG implementation, we use REACT agent as the core mechanism. REACT or reasoning and acting allows LLM not only to generate text, but also to perform iterative reasoning based on the result taken from various tools. To empower this GrapRAG system, we provide 5 specific tools that the model can use depending on user query. The first tool is AQL search. This tool can translate user query into AQL or ArangoDB query language for specific graph exploration. Number 2 is semantic search. This tool retrieves relevant text nodes using vector-based similarity search enriched by graph connection. So user can find all the text that are relevant to their query. Number 3 is definition search. It is a specialized semantic search that extract only definition not in legal term. Number 4 is text to network X algorithm search. This tool translates user query into network X graph algorithm such as community detection, centrality, shortest path, or other metrics graph analysis. Number 5 is visualize query answer. This tool is used to generate visual representation of retrieved data for better insight. All these tools are then integrated into the REACT agent. It will dynamically select the most suitable tool for a given query and return well-structured data-driven response. Here we use GPT-4o as the primary model for the ReAct agent. We also provide Gemini 2.0 Flash as an alternative. Next, we will see some query results of our GrapRAG system. The first question concerns definition. What is the definition of an electronic system organizer? The model accurately identified the intent and utilized the definition search tool to retrieve 10 relevant data points. As a result, it provides the summary of the definition along with its source references. The second question is a natural question about the obligation of electronic system organizer. This type of question is broad and challenging to find relevant data for because of its general purpose, general nature. The model successfully identified this question type to use the semantic search tool, so all the relevant article nodes along with their connected node were retrieved to provide a more comprehensive answer. The third question is a question related to the structure and content of a specific regulation. This type of question is best answered using text-to-AQL because all the main metadata is clearly mentioned. The fourth question is a difficult question because we have to do a graph analysis with an algorithm to answer it. The model successfully selects the NetworkX algorithm search to handle this type of question. It then generates the appropriate code, executes it, and reads the result to the user. Okay, next, the fifth question. The model is asked to do two things. First, find the shortest path, then visualize the result. Because it clearly asks for graph analysis, the model correctly used the NetworkX algorithm search tool to find the shortest path, then wisely sends the result of its finding to the visualization tool to be output. This is the visualization output. Okay, the last query example is used to test the model's ability to solve a more complex problem. It is identifying relationship between nodes and performing graph analysis. The model correctly determines that the initial question can be answered using AQL because of the specific relationship. Then seamlessly pass the result to the NetworkX algorithm tool to further analysis. Okay, after we explore the system process, it's time to see in action in live demo. I will do this by live demo by running model in 3 questions. The first question I want to ask is, what is personal data processing and how does it work? This question basically consists of 2, definition and general. The model will use 2 tools, the definition tool and semantic tool, to get all relevant text that have been enriched and make a summary of the appropriate answer. And here is the answer. This is definition and this is the article. Okay, the question number 2 is, what is the shortest path between article 1 and article 2? Then visualize it. In this question, the model will use a NetworkX algorithm to find the shortest path between 2 articles, and then use the tool and use visualization tool to visualize it. It will appear in the right side. Okay, for the for the third question, the third question is, what article ID that are not effective in permanent Cominfo number 1 of 2010? Then which one have the most legal references? Finally, I want to try its graph exploration ability through this question. The most suitable tool for this task are text-to-SQL and NetworkX algorithm. In order to finding the regulation node first, then finding all the ineffective article nodes and using NetworkX algorithm to analyze them. Okay, with its ability to integrate multiple retrieval and analysis tools, our GrapRAG system presents a powerful approach to legal question answering. It enhances transparency, efficiency, and interpretability in retrieving legal information. That concludes our presentation. Thank you for your attention.